The Bugatti Chiron is the world's fastest and highest-performing supercar, boasting a top speed of 420 kilometers per hour and a 16-cylinder engine capable of producing 1,500 horsepower. Initially, there were doubts that such a powerful engine could be fitted into a car, but the engineers made it happen. However, this achievement presented a new challenge, ensuring the car had sufficient downforce to keep it from lifting off at high speeds. To minimize weight, this all-wheel drive supercar incorporates extensive use of carbon, titanium, magnesium, and aluminum materials throughout its construction. The Bugatti Chiron is assembled in Molsheim, France, at a facility that has crafted dream speed record holders for over a century on its historic estate. The 20-person workforce assembles 16 vehicles simultaneously at 12 workstations. It takes 2 months to construct a single Bugatti Chiron, which consists of around 2,600 components. Its impressive performance comes from the most powerful 16-cylinder 8-liter production engine, allowing it to reach its 420 km/h top speed. 4 intercooled turbochargers generate 1,500 horsepower, enabling the car to accelerate from 0 to 100 km/h in a mere 2.4 seconds. Inside the factory, 4 specialized workstations are dedicated to Chiron assembly, each featuring 2 independent lifting platforms. During production, technicians connect the car's 2 sections. 3 mechanics hand-assemble the Chiron's chassis, while the car's cockpit shell is crafted from 100% carbon fiber, abbreviated as CFK. In the factory hall, 4 steel pins rise from the floor, and 2 technicians begin constructing the assembly platform before placing the 150-kilogram carbon fiber frame onto it. The team then installs a 2.5-kilometer-long wiring harness inside the carbon fiber cockpit, connecting the vehicle's 20 control units. Mechanics use titanium screws to secure the cables to the monocoque. The second stage of assembly involves constructing the rear frame of the supercar. First, a technician assembles the heart of the Bugatti, a 640-kilogram, 16-cylinder engine manufactured in Germany. The engine is crafted at Volkswagen's engine factory in Salzgitter, where a dedicated Bugatti department spans 2.8 million square meters. The engineers working in this department are among the industry's elite. It takes 2 assembly technicians an entire week to create a 1,500 horsepower turbocharged engine. Each workstation in this facility is capable of producing a complete engine component, and the team can manufacture 3 high-performance engines per week. To maximize compactness, every 8 pistons are arranged in a V-shape, and the engine is equipped with 4 high-performance turbochargers. These turbochargers compress air drawn from the front of the vehicle through the turbine before forcing it into the combustion chamber. Turbochargers 3 and 4 activate at 2,800 revolutions per minute to prevent turbo lag and maintain stable performance. The assembly process then moves on to the crankcase, where the pistons have been installed in the 16 cylinders and must be connected to the crankshaft. A technician uses an electronic torque wrench to simulate engine operation, ensuring the piston's movement has no friction against the cylinder walls. The engine consists of approximately 3,700 individual components. The assembly technician installs individual parts alongside the assembly stand, beginning with the fuel pump that delivers fuel to the engine components. The technician then moves on to the generator, which starts the motor and powers other electrical devices. Meanwhile, another technician prepares the oil sump. It must be completely sealed, as it will later be filled with oil for engine lubrication. At an automated workstation, the oil sump's surface is first cleaned with a special oxygen plasma to ensure thorough cleanliness. Next, a layer of black sealant is applied. Once the adhesive is uniformly distributed, the technician has 20 minutes to assemble the components. The technician then positions the oil sump over the crankshaft at the base of the crankcase and assembles them together. Assembly line technicians undergo 2 years of training before they are permitted to work on these engines. Currently, only 8 assembly technicians worldwide are authorized to produce this particular engine. Moving on to Workstation 3, the engine prototype begins to take shape. The crankshaft draws energy from the ignited fuel-air mixture, while camshafts ensure the proper mixture ratio. Driven by a chain, the cams rotate around a metal shaft, alternately opening the valves of each cylinder head in a specific cycle. This 16-cylinder engine has 4 camshafts. To ignite the fuel-air mixture, technicians insert 16 spark plugs into the cylinders, providing the final power needed to start the engine. These spark plugs also influence the performance, fuel consumption, and emissions of the 4-stroke engine. They generate between 500 and 3,500 sparks per minute, creating explosions that drive the pistons up and down within their cylinders. At this stage, all components necessary for the engine's drive unit operation are complete. Since the company's founding in 1909, engine cylinder blocks have been hand-cast, a tradition that continues to this day. Chiron, a highly successful race car driver in the 1920s, won numerous races behind the wheel of Bugattis. The Bugatti Chiron is named in his honor as the ultimate supercar. Once the engine is completed, designers test its performance, with the engine capable of reaching its maximum power of 1,500 horsepower at 6,700 revolutions per minute. The engine is subjected to 1,000 hours of rigorous testing on this bench, equivalent to driving 100,000 kilometers on the road. A large fan cools the engine during testing, while specialized sensors measure over 500 different data points. The test results ultimately form a 3D model, enabling designers to identify potential weak spots. The development of this groundbreaking engine took 3 years, with testing conducted both in the laboratory and by professional race car drivers on professional tracks. Bugatti enlisted former Le Mans champion Andy Wallace to conduct a high-speed test of the Bugatti Chiron. Wallace has test-driven Bugatti cars for over 100,000 kilometers. On this occasion, he aimed to set a new record of 490 kilometers per hour in the Chiron. This marked the first time a production car has surpassed the 490 kilometers per hour speed barrier. The 11-square-kilometer test track features quick alternating turns and straightaways, making it challenging to keep the vehicle on course. At a speed of 136 meters per second, only professional race car drivers could attempt such a feat. As the vehicle accelerates, the rear downforce increases, causing the front of the car to lift like an airplane. Bugatti addressed this issue with an intricate aerodynamic design. After 70 seconds at full throttle, Wallace successfully set a new record of 490.5 kilometers per hour. Back at the Bugatti factory in Molsheim, France, 2 mechanics connect the 7-speed dual-clutch transmission to the engine, which alone is valued at around 300,000 euros. The remainder of the assembly revolves around this engine. Initially, the chassis is affixed to the body's side panel via a lifting platform, which is also entirely composed of carbon fiber. The assembly technician then secures the independent wheel suspension to the carbon fiber frame. Subsequently, the shock absorbers are installed and can be adjusted between comfort and sports modes by regulating the oil flow between damping tubes. The side panel is then assembled on the engine block. The following step involves installing the exhaust system. At the engine start, the end cover temperature can reach up to 500 degrees Celsius, necessitating the installation of a galvanized heat shield on the exhaust pipe. 6 exhaust pipes release gas expelled from the engine and cylinders. The technician then fixes a massive titanium muffler at the rear. Titanium is lightweight, malleable, and particularly heat-resistant, ensuring the muffler won't melt under high temperatures. At this stage, all components surrounding the engine have been assembled. The final step is connecting the engine to the car shell. The entire cockpit frame utilizes 320 square meters of carbon fiber, with the total length of the fibers being 9 times the distance between Earth and the Moon. At this stage, a mechanic installs 2 differentials on the chassis, responsible for balancing speed differences between wheels during turns. The inner wheel turns less and slower than the outer wheel, requiring more torque to cover the same distance. The gears within the differential distribute engine power to all 4 wheels. Brakes are vital for ensuring the Bugatti Chiron, capable of reaching speeds exceeding 400 kilometers per hour, can come to a stop. With operational temperatures reaching up to 1,100 degrees Celsius, heat shields must be installed before the ceramic brake discs. Each brake disc weighs 8.5 kilograms, and the brake caliper is the world's largest 3D-printed titanium component. Technicians then install the ESC control unit, which prevents skidding during fast turns by braking individual wheels. The vehicle's front and rear frames must be combined. Their separate design allows for the rear body to be detached in case of accidents, as engine fires can be extremely dangerous. The front and rear sections are secured with 14 titanium bolts. Technicians connect pipes on the chassis for transporting oil for the engine, gearbox, and brakes. The Chiron's fuel pipes are made of durable polyamide plastic. Headwinds from the front of the vehicle strike two carbon fiber plates, flow through filters into the 4 turbochargers, and compress, increasing the pressure before being injected into the cylinders. This process provides more air and oxygen for fuel combustion, resulting in stronger detonation, greater pressure in the combustion chamber, and linear engine performance. Bugatti's custom-made Michelin tires, 36 centimeters wide, must withstand immense pressure while driving, rotating 50 times per second at maximum speed, equivalent to pulling a 7-ton weight on the road surface. The Chiron is fitted with semi-slick tires, featuring shallower tread depth and lighter weight. Despite enormous centrifugal force, the tires maintain excellent grip, with each semi-slick tire costing €9,250 to manufacture. The supercar is now filled with fuel, oil, brake fluid, and 40 liters of water. The coolant circulates 20 times per minute during operation to protect the engine and transmission from overheating. The Chiron consumes 190 liters of fuel per 100 kilometers. Chassis testing follows, with the car secured to a support frame and the acceleration roller's safety baffle lowered. A technician connects the ventilation system to a fresh air hose to ensure adequate intake air. The vehicle is accelerated to 200 kilometers per hour, and the power unit must undergo 342 tests in total. The engine, gearbox, and all driving dynamic systems are tested for 3 hours and travel approximately 60 kilometers on the test bench before moving to the next assembly station. In the Bugatti Chiron assembly workshop, technicians pre-install the wing on the lifting column and clean and polish the components. These large, fragile components require precise handling to avoid any flaws or damage. Installing the entire shell takes 4 days, with the front windshield installation being particularly complex, requiring absolute precision and sealing. The windshield is installed by applying a primer to the body, a special adhesive to the safety glass, and using an aerodynamic lift to mount the windshield on the frame. The mixture of two components forms an exceptionally elastic resin, ensuring the glass can withstand strong vibrations. Each Bugatti Chiron is a unique masterpiece with complete customization options. Material and color combinations are virtually limitless. The C-shaped design on the side of the Bugatti's body serves a unique purpose, increasing airflow pressure along the side and guiding it into the engine compartment at the bottom of the body. This creative solution meets technical requirements perfectly. The signature horseshoe-shaped grille design is also distinct, though Bugatti had an egg-shaped front face as early as 1910. To enhance the vehicle's aerodynamic performance and cool a larger engine, designers adjusted the grille style based on technical requirements. Interestingly, the one aspect of Bugatti that may not have undergone a lightweight design is its brand logo. Now, the Bugatti Chiron's entire body shell is mostly assembled, featuring complex aerodynamic characteristics that consist of both active and passive systems integrated into the body panels. The passive components are fixed, while the active ones can be controlled and adapt to the vehicle's position and speed. The Chiron is an aerodynamic masterpiece, guiding the airflow over the car and the road surface to cool the brake system. The 1.5-meter wide rear spoiler can automatically adapt to various driving conditions. Upon braking, the adaptive spoiler tilts at a 49-degree angle within 0.8 seconds, generating effective braking force. The hydraulic spoiler is the last of the 55 body panels, which the mechanic is now installing. In 2017, F1 champion Montoya accelerated the Chiron from a standstill to over 400 kilometers per hour in just 33 seconds and stopped the 2-ton supercar in 9.3 seconds after covering 491 meters, setting a new world record. To date, no other vehicle has achieved such outstanding performance. When braking from top speed, the rear spoiler applies a force of 850 kilograms, pressing down the rear axle of the car. In this emergency braking situation, approximately 2 G of force acts on the vehicle and driver. Back at the factory, to ensure the assembled car doesn't get scratched during testing, employees need to cover every millimeter of this supercar with protective film. Applying the protective film takes about 4 hours, and the puffing material is entirely polished. Each Bugatti Chiron must complete around 350 kilometers of testing before delivery. A quality inspector drives the car for over 5 hours, primarily testing the independent driving mode and internal noise, including the creaking sound of leather seats during turns. The car is then driven to the airport runway and accelerated to 300 kilometers per hour. In this test, unleashing its maximum power of 1,500 horsepower. For safety reasons, the speed is limited to 380 kilometers per hour, because any defect at 400 kilometers per hour would be fatal. After completing all the tests, the Bugatti Chiron enters the indoor cleaning facility and is prepared for delivery to the customer. That's the end of today's video. I hope you enjoyed it. Be sure to subscribe to our channel so you won't miss our future content, and I'll see you in the next one.